All right, so given the type of reaction, I can identify the chemical equation and identify as a synthesis, decomposition, single replacement, double replacement, or combustion reaction. Okay, so far we've talked about atoms can combine in different ways to form molecules or compounds. We represent these molecules or compounds with chemical formulas. So when bonds between atoms break and reform, a chemical reaction occurs. Chemical reactions result in the formation of new substances with different properties than those at the beginning of the reaction. Chemical, chemical equation is a written expression used to summarize what's happening in a reaction. For this to be accurate, the way it actually happens in nature, the equation must be balanced. So the reactants are on the left-hand side, and then after the arrow, they become the product. So you'll notice Fe2SO4, some heat breaks into Fe2O3, SO2, and SO3. So you'll be getting to an idea of what those things, what type of reaction this is. So as we said before, there are 5 different types of reactions. A synthesis is reaction, the word reaction, to make. Decomposition makes to break down. To replace with one thing is a single replacement or single displacement. A double replacement reaction to replace 2 things, and combustion reaction causes a fire. So in the synthesis reaction, 2 or more substances combine to form a compound. So AB gives you A plus B yields AB, the product. So here is iron. This is be kind of what we would call our A. Get my pen here. So this is my A, and this is my B, and this gives me one thing in AB. So 2 to 1. How do you tell? More reactants than products. All right, so how can you tell? More reactants than products. So predicting the products of a synthesis, Na plus Cl gives me NaCl. Now we're going to count these up, right? So so we're going to balance these is what we're going to have to do. So in this particular case, NaCl, but we have 2 chlorines on the reactant side. On the product side, we have 2 chlorines and only 1 chlorine. And so that's why we're going to put this 2 here. So now we have 2 chlorines and 2 chlorines, and the NAs get balanced. So that is 2 gives us 1, or more reactants and less. More reactants and products. More reactants and products. All right, in a decomposition reaction, a single compound is broken down into smaller compounds. How can you tell? More products than reactants. So here is our AB that represents a compound, A and B together. H could be the A, and HG could be the A, and O could be the B. And you break it down into an A plus a B. Predicting the products of the decomposition reaction. So here we have this one thing. So our AB. And then we break it down into an A plus B. NaCl, got one AB compound, A and B. So here's the A and the B. Then we break it down into A plus B. Now notice this is perfectly balanced. So the conservation of mass is observed here in all our reactions. And also notice that we get Na and Cl. We don't get anything weird, like we don't get an S or anything like that. It's for sulfur. Okay, single displacement. In a single displacement reaction, one element replaces a similar element in the compound. So Fe, so that's a metal. Okay, and this is a metal and a copper chloride. So there's a metal in here, the copper. All right, and over into the product side, the copper gets taken out and the iron replaces it. How can you tell? Element in a compound, element in a compound. So we still, it's one element and a compound, one element in a compound. They're just switching. So again, an element in a compound, element. And sometimes an element can be like the chlorine. There's an element, here's a compound. And this kicks the Cu out. We end up with an element in the compound as well. Element in a compound. Chlorine and NaBr, sodium bromide, we get sodium chloride and bromine. So they get switched out. And again, it's similar compounds. In a double displacement reaction, ions from two compounds in a solution exchange places to produce two new compounds. So AB and CD become AD, so they take places. How can you tell a compound and a compound? Gives you another compound and compound, but we're switching, right? The Na and the Ag switch places, and we've got AgCl and NaNO3. So how can you tell? Na2S plus HCl, so Na and H switch places. So now we've got Na and NaCl and H2S. Calcium and so here's the calcium switching places here. This part's going to stay behind. So now we're going to get NaNO3 and CaCl2. In a compound or combustion reaction, burning a carbon compound combines with oxygen and releases a large amount of energy to form light and heat. Carbon compound, sometimes we talk about this as a hydrocarbon. All right, form plus oxygen gives us carbon dioxide and water. Product of the combustion reaction is always carbon dioxide and water. Okay, so here you can see synthesis, more reactants, so more and less product. Here we have a decomposition. We have less on the reaction side and more on the product side. Combustion, a hydrocarbon, a carbon with hydrogens, with oxygen. This is an oxygen. Gives us CO2 plus water. Here is a single displacement where the A kicks out B and the B gets kicked out here. So an element and a compound give us a compound and a different element and another element here. And here we have compound switching. So this is a compound. Plus another compound gives us switching. So I like to think of it as dancers switching at a dance. The partners have just switched places. Type of reaction. Okay, so if you look at this, KOH and HBr. All right, so the K kicks out the H in the Br, and the H goes with the OH. So this would be a double replacement. So compound and compound. So this is a double replacement. Right? Mg and CO2, so we have an element and a compound, then we get an element and a different compound. So this is our single replacement. And then PCl3 plus Cl. So we have more reactants and less. So this is our synthesis. All right. So let's look at this again. So this one, 8 FeS, and so we've got A plus B, AB. So synthesis. This is C plus AB gives us a C plus B. So this is our single displacement, single replacement or single displacement. All right, here's the carbon, hydrocarbon and oxygen. We get CO2 and water. So that's our combustion. So we have, this is a breakdown. So we've got an AB, gives us A and B. So this is our decomposition. Cl plus, so this is our single replacement. And finally, this is our double replacement. So the calcium kicks out the Na and the Na kicks out the calcium.